Hi there, this is video tutorial number 2 for CENV1025 Computer Programming and Numerical Methods section. And in this tutorial I'm going to talk about tuples, lists and loops. So we've already learnt in the first lecture and in the previous video tutorial about various primitive types that you can use in Python, like ints, floats, strings and bools. In this tutorial I'm going to introduce two new types, both of which are collections of objects in Python. So let me demonstrate what I mean by an example. So I'm going to create down here in the console something called T, and I'm going to open round brackets and put in some numbers. So we'll have 50.2 and 0.002. Okay, and now I'm going to examine what type this is. And Python tells me it's a type called tuple. So a tuple is a way of grouping together two or more other objects, and the objects within the tuple are indexed with an integer value starting from 0. So in other words, this is index 0 and this is index 1. And I can show you that we can sort of call the individual items in the tuple using this syntax. T equals 0 should fetch the first item, and t equals 1 should fetch the second item. So a tuple's a nice way, and actually we can also do this. Let's have a look at type T 0. We can also inspect the type of the individual elements. So if we look at the type of that, it tells us it's a float. So this particular tuple T is a collection of two floats, 50.2 and 0.02. If we try this t.tab, it tells us what functions we've got associated with the tuple, and we can see we've got two functions, count and index. Let's just see what count does. So in the object inspector up here, it tells me that count returns the number of occurrences of value in the tuple. Okay, so I think I understand what that means. If I put in 3, I should get 0, and that means that there are no 3's in my tuple. But if I put in 50.2, I get 1, so it tells me that there's 1. Okay, so let's try something else. Let's try and change one of the values in the tuple. So I'll select it by calling it by its index, and then I'll change it to, I'll try and assign 50.3 to the value. Let's imagine I just typed it wrong first time around. And now I get an error. It tells me I can't do that. And that is because a tuple is, to use the Pythonic language, is immutable. That means it can't be changed. I can't change the values in it, and I also can't add new values to it. So it's quite limited in what it can do. I guess it's good for particular types of data that don't change and also don't change in length. So this might be, for instance, the latitude and longitude of a building. A tuple might be a good place to store that kind of information, because latitude and longitude always has two values, and the latitude and longitude of a building are not things that are likely to change. So there's another type we can use, which is a little bit more flexible. Let's try this. So if we declare very similar syntax, except instead of using round brackets like we did with our tuple, we'll use square brackets, and we'll put a few numbers in. Hit return, and we'll examine the type of this, and we're going to have a list. Okay, so let's see what functions we've got associated with the list, and you'll see that we've got we've got count again, but we've actually got a few more functions. There's a few more things we can do with the list. It's a little bit more powerful. So let's try this one. This one's particularly useful. Append. So let's append the number 5 to our list. And let's look at it again. Okay, so now we see that our list has gained a new element on the end, the number 5. Now let's try doing what we failed to do with our tuple, which is change one of the elements. So if we try and change L0 to 6, we apparently don't get an error. And if we look at it, indeed, we can see that the first element has changed to 6. Now if you're a little OCD, you might be concerned about the fact that our list now is not nicely in ascending numerical order as it was before. Well, there's a function that can sort that out too. L.sort will get all the elements back in ascending numerical order if that's something you want, and there's other functions as well. For example, L.reverse, you can probably guess what that does. Yeah, there you go. So lists are really useful, a slightly more powerful way than a tuple of storing data that can vary. And so now what I want to do is show you sort of use cases, a couple of use cases for the list, by creating first a function that will generate a list, and then a function that will loop over all the elements in a list, doing something to each element. So case 1. Let's create a function def Fibonacci. Okay? N. A document string saying we want this function to do. I want this function to return a list containing the first n numbers in the Fibonacci sequence. Now, as you all know already, the Fibonacci sequence is a sequence where each number is the sum of the previous 2 numbers in the sequence. So to help us get started, I'm just going to define a list containing the first 2 numbers in the Fibonacci sequence, which are 1 and 1. Okay? Now what I need to do now is I want to add subsequent numbers to the list. And to do that, I want to do something. I want to essentially do that over and over until the list is n elements long. And an easy way to do that is with a process that loops. And the type of loop we're going to use is something called a while loop. So a while loop, actually first of all I'm going to create an index. I'm going to create a variable called I, and I'm going to give it the value 2. So I'm going to call my index. It's going to keep track of the indexes of our list that we need to add to. So we've already had index 0, we've already added index 1, the next index we need to add is 2. So I'm just going to create I equals 2 to help us do that. And what I want is the list, the while loop, rather similar to the if statement that we looked at in the last tutorial, takes a Boolean statement. In other words, it will keep looping while the Boolean statement following it is true. So I could just, for example, type true, and that would create a list that would loop essentially forever unless I had some explicit code within the loop telling me to break out of it. But what I'm going to do is I'm going to say while I is less than n. So in other words, while the index is less than n, keep adding numbers to fib, and when you get to n, stop. So let's try this. We already have seen how to append a number to a list, so we want to append the last 2 numbers in the Fibonacci sequence. Now we've seen how to address how to address specific elements of a list. So for instance, if we wanted to address these two elements, we could call fib 0 plus fib 1, and that would return 2, the sum of those two elements, and that would work only for the next element in the list, because then what we want to do is actually call fib 1 and fib 2 to create fib 3. We always want to call the last two elements in the list, and there's a few ways of going about this, but Python has a particularly nice way of doing it, which is to address -1, and -1 points to the last element in the list, and similarly -2 points to the penultimate element in the list. So this will always call the last element in fib and the second to last element in fib, add them together, and then increase the length of fib by 1. Okay, the other thing we need to do is we need to make sure that our index increases each time we go through the loop. So this first time we go through, the index is going to be 2. We're going to append this index number 2 to this list, and then next time we want to go on to index number 3. So we want to increase the value of I by 1 each time we go through the loop. So we could do that using, for instance, some code that looks like this. I equals I plus 1. We'll just increase the value of 1 each time it goes through the loop. And in fact, there's a nice shorthand in Python for doing this, which is I plus equals 1. It's a nice shorthand which basically means exactly the same as what we typed before, I equals I plus 1. And then finally, we want our function to return fib. So let's have a play with this and see if it works. Let's print fib. Yeah. Print Fibonacci, and let's give it 10. Let's run that and see what happens. Okay, so that's printed out a list containing the first 10 numbers in the Fibonacci sequence, which is great. So let's actually just let's try. The functions worked, but let's try stepping through it just to see what's happening. So what I'm going to do now is I'm going to use the debugging controls again. I'm going to create a breakpoint. I'm going to start debugging. I'm then going to press fast forward so the code will run until we hit this line with the breakpoint in it, at which point I'm going to step into the function Fibonacci. Step in. And let's check out the variable explorer and see what's happening. So we've got this you can see in our variable explorer we've got a variable called fib, and if we have a look at it, inspect it, we see it's got two elements in it, 1 and 1. Okay, so this is exactly what we've declared, and we've got an index variable 2. Okay, so now we drop into the list. The first thing we do is fib append, so we check fib again. We'll see we've now got a new element has been added, the sum of the first two. So we've got 1, 1, 2, and if we step once more, our index gets increased up to 3. And now what the code will do is it will just keep looping through the list. At each step we add a new value to the list and we increase the index by 1. So let's have a look where we've got to now. Now we've got 8 items in the list up to the 8th Fibonacci number. So we've got 8 elements in the list, and the index has gone up to 8. So if we just keep going, we'll get 9, and then when I gets up to 10, this statement is suddenly going to be false. So it's been true up to now because i's always been less than n, where n is 10, what we've passed here, and now we've got I equal to 10, so this is false now, this statement. So what's going to happen when we step is we're going to drop out of the loop, we're going to stop looping, and we're just going to head to the return statement. Okay, so that's a function. That's an example of a function that can build a list. Obviously we can try different numbers. We can try 20. Oh, we can try 20, and you'll see we get printed out the first 20 numbers in the Fibonacci sequence. or we can try quite a big number. We could try 10,000, for example, and print out. Oh, I keep pressing the wrong button. Print out the. Oh, it's taking a while. Yes. Okay, so that took a little moment. The computer had to think for a moment, but then it printed out the first 10,000 numbers in the Fibonacci sequence. Okay, just let it recover from doing that. Actually, it did it twice in a row because I clicked the button twice. Okay, let's just reduce that to 10 so it doesn't do that next time we run. Okay, so now I want to create a function that will loop over a list and do something at each point in the list. So I'm just going to do something really simple and create a function called double Fibonacci. And the first thing that I want this function to do is, well, first of all, I'll give it its docstring. Return a list containing the first n numbers in the Fibonacci sequence doubled. Okay. So the first thing I want to do is build my list using the first function we created. So fib equals Fibonacci n. And now what I want to do is I want to create a loop that goes through each of the elements in fib and doubles them and adds them to a new list. So I'm going to create a new list called double fib, and I'm going to create this list empty with nothing in it. Now I'm going to use another type of loop. We've seen a while loop. This is a slightly different type of loop called a for loop, and I'm going to use this syntax: for element in fib. So what that's going to do is that's going to loop through each of the elements in the list fib, and at each consecutive loop the value element will equal the corresponding element in fib. So just to show you exactly what I mean, I'm going to try just printing out element. So I'm just going to make this function return none for now. And I'm just going to call it down here. Double fib 10, and we'll press run. Okay, so what's happened here is you see on line 19 here we've done our normal print out the Fibonacci sequence, the first 10 values, and here I've done the same thing. I've run the double Fibonacci function, and it's looped through the list fib, and at each loop is printed out that element. So you'll see it's printed out 1, 1, 2, 3, 5, 8, 13, 21, and so on. So what we actually want to do is, at each step, we want to add to double fib dot append. We want to add element times 2, and then what we want to return is double fib. Okay, and we'll just have print here. So what that should do at each point in the loop, it should take the element, multiply it by 2, double it, and add it to this new list, and then we return the new list, which is the double Fibonacci sequence, for want of a better term. And so there we go, we've run that, and we see on line 19, print Fibonacci, we print out the regular Fibonacci sequence, and on line 33, the next thing we print is the doubled Fibonacci sequence. Okay, so that's just a brief expose of lists and tuples, and also loops, which are kind of intimately related to lists and things like this, where we kind of go around and do the same thing many times over, either creating a list or reading over a list. Okay, the next tutorial will be about file input and output.